Okay, so we're here on page 3, and it's mostly just some reminders. So if you look on page 163, it's the book's version of talking through what you can do to inequalities, and it's basically saying you can still have the addition property, you can still add the same things to both sides, which is, and subtraction is really adding the negative, so, or adding the opposites. So it talks about you can add or subtract from both sides. Then it talks you through the positive multiplication property, which means that if you multiply or divide both sides by a positive, nothing changes either. And then here is the exception, the negative multiplication property of inequality. I'm not interested that you memorize the name of this property, but you definitely want to memorize what it means, what's happening. It's everything we've been talking about. It's the one exception to inequalities. If you multiply or divide both sides by a negative, it flips the inequality. So it's just another way the author's talking you through it. Let's slide down to the next part of the video here, or the page, sorry. And again, another reminder from the book. On page 165, it walks you through the steps for how to solve a linear inequality. So it talks about simplifying like we do. It talks about you use the addition property, then use the multiplication property, and then if it's it talks about it as changing the sense of the inequality, changing the direction of it. If you multiply or divide both sides by a negative number. That's the key. That's the critical difference between everything we've done so far in Chapter 2 and now looking at inequalities. So from there, solve each inequality, graph the solution set on a number line. Here's a couple try problems, number 48, number 54. So I'll give you a chance to pause. When you come back, after you've tried these, I'll show you the inequality answer, the number line answer, and the interval notation answer. Okay, so the inequality version of the answer would be x is less than -3. On a number line, you would have 0 as reference, -3, and sometimes plugging in 0 into the x value of your solution and see if it's a true statement or not will help you know which way to shade. If it's true, shade the part that includes 0. If it's not true, shade the side that does not include 0. In this case, we're going to go to the left. X is less than -3, so it'll include all those values to the left all the way to -infinity, but it won't include -3, so then we have this open parentheses here. And then the interval notation goes from -infinity, comma, to -3, and both of those will have parentheses. Parentheses, -infinity, comma, -3, parentheses. Okay, let's look at number 54. As an inequality, you would get y is greater than or equal to -1/4. Or you could write that as -0.25, either one. For an number line, you'd have 0, 1 maybe as a reference as well, so that you could see what -1/4 kind of look like. I've got -infinity to the left, positive infinity to the right. I think I said 1. You want -1 there as you go to the left for a reference point, just to kind of help you gauge where you're at. And then we want all values greater than or equal to, greater than or equal to the -1/4. So we're going to take everything to the right of that. 0 would be a true statement there. 0 is greater than or equal to -1/4. So it would get included in the shading here. And because it can be equal to -1/4 as well, we'll go ahead and write it in as a closed bracket. And then the interval notation would be just that, from -1/4, comma, positive infinity. Infinity always has the open, and we would include -1/4, so we'd use the bracket on the interval. So bracket, -1/4, comma, positive infinity, parentheses. Or you could use the decimal version. All right, we'll see you on page 4. Short and sweet.